Okay, and this means we are now with the last finalist, and we are actually leaving Germany and going to London. Although the example is from Deutsche Bank, Alan and James are sitting in the UK and joining us to also touch rules, data quality rules, and we've seen they are essential, but we've the approach, which is a self-learning approach, so where you use data science, advanced analytics, machine learning methods to improve data quality. And the floor is yours.
Good afternoon, everyone, and thank you, Christine, for the introduction. So, my name is James Whale, and my role is Head of Data Quality Management at Deutsche Bank, based in London. And Alan runs the data analytics function based out of Dublin. So what we want to talk you through for the next half an hour or so is something we built, which is called Autodq, which is our machine learning methodology for accelerating the accurate discovery of rules for data measurement. So if we go forward to the next slide, thank you. So when we were thinking about putting a presentation into Christine and Tobias, we sort of took the CDQ model and thought, where does Autodq focus on the excellence model? And if you go to the next slide, we think that it does actually, highlighted here in red, cover a large part of what CDQ is about. The big focus really has been on sort of creating something for the business where it gives the ability to discover errors in data as quickly as possible through the organisation and avoiding a lot of the latency that we previously struggled with through a very complex architecture. So if we go to the next page. So as a bit of a recap, 3 years ago, we came and gave a presentation on something we called DQ Direct. And this was our technology to consolidate the way that the bank understands and collaborates around data quality. It's a issue management workflow tool that is now fully adopted across the organisation. And we now are quite confident we can go and speak to anyone, whether it's our regulators or whoever, and say, this is the complete set of data quality issues in the organisation at that point in time. But the challenge we've always previously had has been that a lot of the discovery has come from the processes, and it's therefore been from where the process breaks down that the discovery is made. And that's often at the very end of the process, and that means to then identify the underlying cause of the issues requires a lot of that detailed analysis that I'm sure most of you are aware of in terms of taking that detailed root cause up through the systems, through the lineage. So we wanted to remove the cost of doing that and put in place something that will auto-discover and auto-detect the rules at source. And that's Autodq, which we'll talk to you about now. So the next page, thanks, Sam. So we put this page in because I think it's important just to frame and give context to the challenges we have. Because when we look at the data that we consume in the organisation, only about 10% of that data is data that is correlated with our sort of primary trading functions, if you like. So if we need to book a financial transaction, no more really than 10% of the data in the organisation ends up being sort of directly needed to create that trade. The challenge we have is that most of the data is needed downstream for the infrastructure functions for reporting. Now, Christine mentioned earlier on about that Citibank fine of 400 million for not maintaining a data management function in a banking organisation. And DQ Direct is the way that we avoid that. But the challenge we have is that we have this very large amount of data under the water, if you like, and that means that a lot of the data gets created downstream with the consumer functions, and therefore when there's challenges to that data, the problem we have is there's an awful lot of systems and pipes that need to be understood to understand where that data challenge has gone wrong. I mean, just one example that we deal with is in the US, one of the big federal boards some of you may know, it's called a Y9C. It's the annual sort of banking statistics report. And in there, we have to report around 650 different statistics on banking alone. That is a huge challenge, and that means that a lot of that data, therefore, is under the water, as it were. And that's the problem we're trying to solve about. When there are challenges to that data, how do we discover the underlying source? Okay, so we'll come back to this in the wrap-up as well. But where we see on the next page, things where we see this being highly correlated with the DQ model is on the gold side. What we are delivering now is a front-to-back DQ toolset that does this discovery as well as the analysis and remediation. It helps us improve the lineage of DQ issues through to the source, and it provides a lot of the costly root cause analysis that is expensive and time-consuming. And also, it helps us to avoid a lot of the manual interventions that currently happen downstream in all of these processes. So the enabling functions we then have is a single enterprise-wide tool now that ensures that the internal stakeholders have effectively one tool set to use and are not persuaded to use alternative methods to do the same sort of discovery analysis. It means we now have a very efficient sort of cause and effect model as well, that we can actually see the rule breaking and we can see the underlying DQ issue and connect them to give the business context to the rule fail. And overall, this has meant that, and as I will talk you through the model in a moment, we have ended up producing something that is very low cost. It's something where we own the code base ourselves, and it means that the cost of remediating and understanding DQ issues is now greatly reduced since the implementation of this tool. Okay, so now I'm going to hand over to Alan, who's going to take you through some more of the details.
Perfect. Thank you, James, and thank you for the invitation to come and speak with you today. So what I have in the next few slides is really just a walkthrough of Autodq, looking at a bit about the motivation, but the majority of the material I have here is really about the solution. How we've put that together, and there's a quick video run through of the screens themselves, which I think will help to illustrate how we've integrated the tool and put it in the hands of the business users. So a bit about the background. Deutsche Bank, I suppose, is quite similar to a lot of large organizations where our data quality rules have been drafted, created by rule developers and run across various data sets. So just to give you an idea, we have a business rules engine within the Chief Data Office. And last year we ran just over 51 billion checked through that rules engine. So this is an effective way of checking data quality, and it will validate if an attribute or a field has passed the test or not. However, there are some drawbacks, and these drawbacks really speak to some scalability challenges, and also as data changes and evolves and new attributes and fields get added, there's always an incremental amount of effort required. So we wanted to look at this and see if there's a better way. So we wanted to address, the very specific rule requirements that are required from the business. That can lead to a high error rate. We wanted to really collapse that development cycle. So move from a situation where there's a piece of work to really develop the rules to then put them into production, run them, and then get the results at the end. We wanted to see how do we collapse that and make that something that is quite a bit quicker, and really reduce that onboarding process. So the approach that we have, and if we can take BORE, which is our business rules engine, and what we kind of call the legacy approach, not legacy as in we're going to get rid of it. It's still a valid thing to have. For example, if we have a regulatory requirement for a very specific type of test or data quality check, we would go and develop that in the business rules engine. And that standard flow really looks at ingesting data. We use our enterprise analytics platform for that ingestion piece. We then, engage in a discussion with the business and with the data set owner to agree what rules should be developed. They go through that development, test, and release process, and that can take, in the best case scenario, you're probably looking at about a week. However, it can be longer with this competing priorities. This can drag on, so beyond 1 week, it can get to multiple weeks. And it's only at the end of that process that you start to get results that can be then analyzed on a dashboard and action taken. So the Autodq approach is we ingest the data. We have a very quick training cycle. This can be as short as 25 minutes, depending on the data set. I mean, it can be shorter than that again if it's a very small data set, but we have a short training cycle. And then the results become available. So we make this significant time saving to go from here's a data set that has no data quality rules or is not fully covered. It might have one or two, but there might be 100 attributes, to having a set of results that can be then analyzed and used and provide insight as to the data quality issues. So the way that we approach this problem, so we knew some of the areas that we wanted to tackle, and in terms of approaching it, we wanted to be sure that we took a look at the market and really tried to understand, broadly speaking, what functionality exists. So we partnered up with the innovation team within the bank, and we went and spoke to 7 vendors that had tooling in this space. Okay, and they were all deemed leaders and with capability that could help us. So we did find that there was powerful functionality for data matching and cleansing. We found that anomaly detection was an area where these vendors had a strong skill set. Drag and drop rule creation. So this was really a way to take the developer out of the loop and really give the rule creation tooling to the business user, but they still needed to create rules. And then there was also a number of vendors who provided overall data quality management hubs, which kind of combined a number of different things. We came across one vendor that could provide this automatic rule generation that we were looking for. However, there was a significant cost, and the vendor provided a kind of bundle service. So there were a number of things that we didn't necessarily require, but they would come as part of a purchase. So as James mentioned, we've been on this journey for a number of years, going back to 2017, and we've built up the bank's data quality tooling. So we have a well-embedded, well-adopted set of tools, and we felt that the best thing to do was to try and enhance that as opposed to bring in an overlapping tool set. So we turned and took a look at open source options to see if we could build this in-house. And by building it in-house, we have the integration benefits, but we can also leverage the team that we have who look after the existing tool set. So what we found was, the benefits we were going for by taking this approach is easier integration, lower costs, keep that know-how in-house, that intellectual property, and then, given the year that 2020 has been, avoiding difficulties trying to go through a vendor engagement process in the middle of a pandemic. This wasn't something that we were willing to just put on the long finger and wait until 2021. We wanted to progress. At the start of the year, and we need to keep going even as the world went into lockdown and the end of Q1. So what I want to do now is maybe just talk a bit about what Autodq is, just to give you a sense as to how it works, and then we get into the screens a little bit later on. So really, as a description, it accelerates data quality measurement. It automates content analysis. Okay, so if you think about the old process, you need somebody to sit down and eyeball and work through the data. We try and speed up a lot of that, and it's built to scale. So some of the technology choices that we've made have kept in mind the vast data that we have within the bank. So looking to get to thousands of data feeds and billions of rows of data. So the way it works is looking at this chart here and going from left to right. Autodq will take in a tabular data set. It takes it into our enterprise analytics platform. This is essentially our data tooling, our Hadoop instance. and it runs it within Apache Spark. So the reason we use Apache Spark is for that scalability. This is a very, very quick, almost infinitely scalable location for us to run these rules. And then what it does is it runs a set of metrics. It runs a battery of statistical checks on the data to really interrogate each of the fields and then suggest rules. So with those rules, they go back to the owner. They can be reviewed, and then there's a decision. Do you want to activate these rules or not? Once they've been activated, we then start running those rules and passing out results. And I'll show you what that looks like in a second. And as I kind of, everything in this blue box is really the engine room. And this is where the analytics developers based over in Dublin build out the tooling. And then outside of the box are the areas that we have our business users interacting. Okay, so Data Metrics Hub is where they go to look at dashboards and metrics and really understand trends over time. And DQ Direct is the location for booking an issue and taking it from this, we do some measurement, we identify an issue, and then we want to resolve it. It goes into DQ Direct. And then what we have are a series of data councils who will look at those issues and apply the right resource and funding to resolve and address those data quality issues. Excuse me. In terms of how, I've got a couple of slides here just explaining how we do that rule generation piece, okay? So what we do is Autodq first runs a profile of the data and applies a set of checks against the rules. And then what it will do is it'll in the background and hidden to the business user, it'll generate for each of the attributes, it'll generate a number of different pieces of analysis. So for example, a simple one is a data type analysis. So it'll go in and look, right, so remember this is a hands-off process, so we don't expect our business users to have to do anything other than provide a good training data set. So one of the things that needs to figure out is, am I looking at numeric data or string data? If it's numeric, is it integer or date or float? So it will do that check and ascertain that. That then leads into the next series of checks. So if it's, for example, a string, so it's text, you then might run a check like this, so just to measure the length and find out in that field, is it pretty consistent or does it vary? If it's numerical data, you can then do other things like look for maximum values, minimum values, mean, standard deviation. You can look at things like completeness. How is this a sparsely populated field or is it complete most of the time? You can look at unique value ratios. So if you have a field that's always unique, it's a good indication that it may well be a key or a unique identifier. If it's a field that tends not to be all that unique, it's some kind of categorical value. And all of these metrics, and this isn't a complete exhaustive list, but all of these checks, as you can imagine, provides more and more insight to each one of those attributes without anybody having to develop any code. So to kind of give an illustrative example of that, so if we imagine that this table here is the data set that we've passed to AutoDQ, and we scan it. So what would happen in this scenario is a rule will be generated for the name field here to say that it's mandatory. So it uses what it's given. It assumes that what it's given is a good example of the data, and it creates the rules based on that. Now, there are opportunities for the business to override and tweak these things, but this is a starting assumption. So it assumes that name is mandatory because it's been populated in all these examples. For the age column, it can tell a few things. I can say that it must be an integer. It's an integral value. The age, you can't have a negative age, and that field is also mandatory. There's a view here that opening date must be mandatory. We can tell account active, it has categorical values, but there's only 2 of them. So it can say, right, it should be mandatory because it's always populated, and it can tell that these 2 values are valid. If, for example, there was a third value, NA, and it just wasn't on this data set, that could be added later. But it gets the first iteration of the rule up and running. And then for the final field here, it can tell this isn't necessarily mandatory because it does have some blanks, but it can say that the acceptable values are current and child. So that's really what it's aiming to do, and go from no rules to a set of rules that can then be reviewed and managed by the business. So that's a bit about the mechanics and how we get a set of rules on a data set. This then talks to the process and how the business interact with the results. So we take the same starting point as I showed earlier, that input of the tabular data into Autodq, and a set of rules have been generated. What happens next is the business users review and they choose to approve or dismiss. If a rule gets dismissed, so really the action there is that the rule isn't going to add value or isn't required, so it gets dismissed. It doesn't get deleted, but it gets put to one side and it won't generate exceptions. If a rule is approved, this is the business user putting it into saying, yeah, this is something that I want to run over this data set and I care about the results. So we capture in the system, we capture who made that approval, when they made the approval, and then we push it into production. And what happens is those exceptions get generated, and then they come back into our tooling with the exception results, and it's up to the business user to say, I want to log this now as an issue. So that, as you can imagine, that whole flow takes us from I have a data set all the way through to I've identified the issue that I have, and I want to apply for funding to address this. I want to go into the workflow, and I'll cover that in a second, to get this fixed. So it's all about trying to drive and get to real remediation of issues as quickly and as frictionless as possible. And that takes us to the DQ Direct issues piece. So that's how the business interacts. I thought it was useful maybe to talk a bit about, so if we go back to the start of this process, we took a very iterative approach, right? So we started out and wanted to work with our data practitioners and our data councils to really understand, make it clear to them what the potential of this type of tooling, and provide some real examples. So rather than kind of coming along with a theoretical idea, we wanted to kind of make it real. So what we did was we ran a very quick proof of concept. So we took a data set that we were very familiar with because we had developed the rules in the business rules engine, and we put it through Autodq. So we set out 3 areas for success. And we did, we genuinely wanted to operate on an agile and fail fast approach. If we couldn't meet these criteria, if we couldn't prove success, then it wasn't something we're going to take any further. So the 3 things we wanted to prove: one is develop a pipeline to ingest the data set into Autodq. The next was to benchmark Autodq against the existing business rules engine approach. And then we wanted to make sure that it would be significantly quicker. So we weren't looking to shave, 10 or 15% off processing time. We wanted to make a significant improvement. So if you take the benchmark as 5 days, we wanted to be down below a day. The scope that we took, so we put this over 199 attributes or fields. We ran it on training data from the very start of the year, so Jan to Feb. It was around about 1.2 million rows. And then we tested that. So the training data created the rules, and then we tested it against data that we hadn't seen. So this ran up until the 10th of Feb. So we took data from the next day and then analyzed it. And what we found was really, really encouraging. So the first thing is onboarding to Autodq is 80% faster. So we did hit that reduction from 5 days in a best case scenario down to 1 day. We found something also very interesting, which is some of the debate and discussion we had was, could an automated approach actually generate rules that would be useful? Okay, so there's a feeling that perhaps it could generate the content-based rules would only be a small fraction of what would have to be generated in total. And we found that actually the opposite was the case. So in this example, 88% of the rules that had been manually developed using the legacy approach could be automated with Autodq. Right? And when I say, it takes it all the way from it creates the rule, it figures out the constraints. So, if you have a value, it'll figure out, what those values should be and go into production. So all the way through for any given data set and every single attribute there. So it really was a significant accelerator. We also found that more attributes could be covered. than those that you would create if you have to have manual developers, and this stands to reason because the way the process is set up, it'll look at every field in a data set. And then we also found that more rules were generated, so we give the users more options. So when you automate and look at all the content, you can pass out more rules for activation. So that was encouraging, and it really kind of pushed us on to the next phase. So we went from the proof of concept phase into a pilot and ultimately on into production, which is where we are now. So in September, Autodq went live in bank, and we started just earlier on this year. So it's something that we're very proud of. We also listened to what we were hearing from our end users, and that was that they wanted to be in control through this process. So the automation was welcome, but what they didn't want to have happen was that we automated everything and took the business user out of the process completely. So what we've done to mitigate that is we've ensured that Autodq has user involvement at every step along the way. So at the very start, the users will decide what data gets enrolled and put through Autodq. When the rules are generated, we have screens which will enable the approval or dismissal of those rules. And in future iterations, they'll be able to even tweak them. So you might remember the example I gave earlier had valid values were Y and N. If somebody wanted to put in NA, that they could go in and tweak that. That's a future iteration. So there's a lot of control over the rules. And then finally, the things that the exceptions that make their way into DQ Direct as an issue and get management attention and requests for funding and support. That's also a step. We automate it almost completely, but the pushing of the button to take it from an exception into an issue is fully in control of our business users. So I mentioned earlier the process. So what we have here in the central flow is the way that we manage data quality issues from start to finish. So, it starts with raising them, there's some validation, there's some remediation, and all the way through to close. And this process stays true regardless of how an issue gets raised. So be it manually raised or from the business rules engine. However, with Autodq, we recognize there was an opportunity to speed this up. And I think, thinking about this as almost a mental model for everything that we're trying to do, it's how do we collapse and make this as quick as possible to go from I have an issue all the way through to it's fixed. So what Autodq does is when an exception is raised and a user decides that they want to put it into DQ Direct for resolution, we can skip the raise stage, we can skip the validate stage, right? Because we know the fields, because we grab the metadata from the Autodq engine, we know that the data that's flowing in is valid, and we don't need to put any time or effort into manually checking that. So that the issue straight away starts here. So it gets a head start, and it can get right into here's an issue, and we'd like it to be reviewed by the relevant data council and prioritized. So it really helps us move this process along quicker. I think it's a template for how we can speed things up going into the future. So what I'd like to do now is we have a video, it's just under 7 minutes or so, of a walkthrough of the tooling. I think it might be a useful way just to show you how a business user interacts with this and how it links up with our metrics hub at the end. So I'm going to play this now and I'll make it full screen.
This demonstration will focus on our enablers for data excellence, which are creating a single discovery to remediation lifecycle and an efficient process for the identification and application of DQ rules. This is DQ Direct, our bank-wide workflow tool for capturing, prioritizing, analyzing, and remediating data quality issues. The Autodq user interface can be located within DQ Direct. On the menu on the left-hand side of the landing page, there is an icon for DQ measurement. This will open up the Autodq screen. Integrating Autodq and DQ Direct is how we ensure that the user has a single process for the entire life cycle of issue management and remediation. The ability to approve, dismiss, and generate DQ direct issues is restricted. Here in the Approver section, users can see which approver groups they belong to. The approver groups correspond to different divisions of the bank. The user interface is divided into 3 sections: the Live Rules Store, the Dismissed Rules Store, and the Exception Control Center. The table on the Live Rules Store shows all rules that have been generated, both approved and unapproved, excluding dismissed rules. Rules can be approved or dismissed by checking the box and selecting Dismiss Rule or Approve Rule. The rule status will update to approved once a rule has been approved. An approved rule will go on to generate exceptions if data fails the check. Dismissed rules will move to the Dismissed Rules Store. The Dismissed Rules Store shows all generated rules that have been reviewed and dismissed by Autodq users. These rules will not generate exceptions, and the rule status in this screen is dismissed. Rules can be reinstated by checking the box and clicking the Approve Rule button if the rule is dismissed in error or if a user changes their mind. The next section addresses our biggest challenge, which is simplifying the process for capturing DQ issues accurately. This is the Exception Control Center. This shows exceptions for approved rules aggregated by rule ID. Users can see the count of exceptions versus total checks, and the latest date that exception was identified. Exceptions can be removed from the Exception Control Center by dismissing the rule to which they relate. This can be done in the Live Rules screen or here in the Exception Control Center. Where a DQ direct issue has not yet been raised, users can generate a DQ direct issue by clicking the button in the Action column. Autodq will automatically populate 85% of the mandatory fields required to log a data quality issue. Users need only populate the legal entity, recurrence, and enterprise data model field before submitting the issue. Legal entity is required because the feeds are not entity-specific. The enterprise data model field is required to ensure all DQ issues are described in a standard EDM language, which is used to categorize issues into themes. Recurrence is helpful to understand the operational impact of an issue. Once a DQ direct issue is generated, the issue ID will appear in the case number column. This issue will enter the workflow at validation complete stage, ready for prioritization. The issue can then be viewed in the inbox area of the tool. The mandatory fields within the issue ticket get populated by the metadata from the rule and the exception information. DQ direct issues will also be presented in our interactive analytics dashboard. There are a variety of views available in this dashboard that allow our users to analyse and report on data quality issues raised, both from Autodq and those raised manually. Here we can see, for all critical issues, the data council that raised them and the status they are in. Here we can see all of the issues submitted over the past year. And here we can see all issues, what status they're in, broken down by materiality. These views help to ensure effective tracking and managing of data quality issues once logged. This concludes the demo of Autodq.
Great, thank you. Now we can go back to the back to our screen.
Perfect. Okay, thank you. And thank you for stepping in. I can't see the presentation, but I could hear, so I'm quite familiar with it. The next few screens, slides are really just, I suppose, covering off in a bit more detail. What was covered in the video, I'm not suggesting that we go through them now, but I guess, James, back to you maybe to just wrap us up.
Yeah, thanks, Alan. Okay, so just coming back then to the CDQ model and where we feel this adds most value. So on the business capability side, as we said before, this has helped us to avoid the costly root cause analysis. We don't have that many people in the organisation who have been here so long to understand all the tunnels and passages that link one organisation to the other inside Deutsche Bank. So avoiding costly root cause analysis is pretty key for us. It also helps us get very clear ownership, because a lot of that analysis challenge is creating a body of evidence to make it clear where the problem sits. But if we're measuring this very clearly at a point of exchange, then that problem disappears very quickly. On the data management side, having a fully integrated platform end-to-end ensures that we get proper engagement and the organisation uses the entire DQ toolset rather than modules, if you like, and that ensures that there's much more consistency across the whole sort of remediation life cycle. Okay, next page, Anne, the enablers. Right. So on the enabling side, so having that sort of complete front-to-back life cycle management is absolutely key to us, because it means that we have that full connectivity between the discovery of the underlying problem and the impact it's having on the business in terms of the articulation of the data problem, which can then be prioritised against other issues. On the performance side, we have got the fact that we have this self-service module and built that it gives a much more flexible engagement to the users. And also through the implementation of these tools, we've now got to the point where there is a board level KPI on data that each division is managed against. We call them board level -1, but effectively that means that each division in the organisation is held accountable for improving its underlying data. On the process side, then we, as Liz was saying on the video, we link everything through to the bank's data model and to its process model, and again that ensures that we've got consistency from one issue to the next. And having that common language across all the measurement and all the DQ issues means it's very easy for us to then plug into the bank's big data programs to understand where these issues need to be fixed. Okay, and the goals page, next page. So it's single design. It means it's easy to integrate that whole tool set into other data management tools in the organisation, especially ones for governance and for architecture. And on the business value side, we own the code. We don't have to buy the licenses. We're not dependent on a third-party vendor to supply the tools. And the benefit in accelerating that data discovery for us is huge, and making sure that we have a very quick sort of triage process right through to the underlying problem, and it saves us an enormous amount of time and costs across the whole organisation. Okay, so where do we go next? Next steps. So the next page, thank you. So at the moment, the biggest trading division is is a large user, and our biggest infrastructure function, sort of regulatory and compliance area, is also a big user of the function of the capabilities. Our next rollout will cover all the other consuming functions of the organisation, because we're going to integrate this into a new strategic data store. That will be the point where all the consuming functions, finance, risks and treasury inside the bank will take their data from. And Autodq will be the means by which the data is measured before going into that centralised function. On the technical side, Alan talked about the handwritten rules component of the business rules engine, and there'll be further integration of that, which is really just an enhancement to the capability that's already there. And we'll just continue really to sort of improve some of the way in which we improve the discovery of the rules, including some more patterns and other sort of types of rules going forward, which is really just a sort of an extension of the capability that's currently there. Okay, so thank you for that. That takes us to the end of our presentation.
Okay, Alan and James, thank you very much for these insights into rule mining and how you use it. We have a couple of questions, and I just got also Eva's agreement that we give you a little bit of time to answer those due to the time that we have lost in sorting out the technical issues. There were a number of questions that relate to the context on which you apply those rules. So in the sense of, do you typically have data that is already cleaned? And exactly, and is it more master data, transactional data? So can you give us a little bit of an idea on which type of data you apply those approaches?
Shall I start, Alan? You can fill in on some of the detail. But yes, it covers a lot of master data, so it will cover a lot of transaction data. It will also cover valuation data that has to be added to the transaction data to give the context and the business value to it. And it will also include the reference data as well. Is the data clean? It varies from those sources that maybe have already been through a strategic program and have adopted all the master reference data sources already, in which case they are as clean as the reference data. But we still have a long way to go there, and there's still a lot of areas that use their own reference data tables, and will have sort of data quality issues as a result of that. But also because a lot of these issues historically being discovered at the end of the process, it's taken a long time to get the almost like the legal case, if you like, of why they need to fix the issue up to that level, because of the amount of root cause analysis that needs to be done. So what this does is it just gets us to the point straight away. You measure it before it gets to anyone else in the organisation. There's no ETL, there's no transformation. It's very clear that the data is already wrong before anyone consumes it.
There was also the question of how you actually have the process of correcting the wrong data, or on the one hand side, or how do you leverage the data quality controls that are in the source system? So these are two types of questions mentioned by Martin Böhlen and also Thomas Baudet.
So on the correction side, what we've done is used effectively this enhanced quality of the problem statement to map the biggest data quality issues into the bank's strategic programs. And while Alan's been building Autodq, in parallel, we've been then mapping all the big data problems into strategic programs in the organisation. So where we are now is that we use a consistent materiality rating on all issues, so that all issues are objectively rated against each other. And 75% of the biggest data quality problems in the bank are already mapped into data programs for remediation. And 12, 18 months ago, we didn't have that at all.
Okay, then there was this question about whether you also identify rules that cover dependencies between two or more attributes. It may be that this was mentioned also in your patterns that you try to do in the future, but I let you answer.
Yeah, I might take that one. That's really kind of a future focus. So right now we've been focusing on attribute by attribute, and it's almost like building up layers, right? So we wanted to start with a consistent attribute by attribute type set of rules, and then what we look for next is that inter-attribute relationship, right? And the reason why we've taken it that way is it obviously gets quite a bit more complex. So there is more of an overlap between the types of rules that might go into the business rules engine anyway, right? So when you get to kind of nuanced business rules, we feel that kind of final 10, 15% of rules, it's actually okay to have manual effort on that because they tend to be quite precise. But we do think we can automate some of it. And what we're looking at is, taking in a data set and without having an explicit rule, being able to kind of figure out, okay, so, where country is Germany, currency euro is, a significant percentage of the time. So having, a US dollar in that column is possibly an issue, right? And trying to make those comparisons so that would combine, country with currency without anybody having to express it. And again, I think we'll use the same delivery model where we'll serve up these suggestions to our business users and say, here's a pattern we found. This looks like it's problematic, and we'll have them confirm or dismiss. But yeah, that's very much of the roadmap because I think it's quite powerful, but it is it's a smaller problem to solve than what we've gone after initially.
And another question probably also to you is how do you avoid actually to get too many false positive rules so that you do not overload the business user with a lot of rules that actually would not be of interest?
Yeah, it's a good point. So what we do what we have planned, right? So this is in the next iteration in early Jan, is that it will be possible to do two things, right? So one is to turn off the fields that require rules rather, and the second is to give the user the ability to turn on and off the types of rules that they would like activated. So I kind of mentioned that there's lots of different types of rules. They can kind of bring that down to a subset, and they could say, right, we have lots and lots of very wide data sets in the bank running to 200, 400, 500 attributes. A given user might only care about 10 of those, so they can just be manually turned on and say, right, run the process over these 10 fields. That's one way. I think there will also be kind of a reinforcement over time. So as we learn, the actions that are taken off the back of rules, we'll probably be able to make some smart suggestions on this as well. But that's one way that we kind of can see helping with, creating too much noise or too much of an overhead going forward.
Well, I think also it's worth saying that the rules as they stand now don't necessarily show false positives. They more maybe show negatives, but maybe on attributes that people care less about. So it's we're pretty confident that the results are genuine. If you know what I mean. It's then down to the user to determine which fields they care most about.
Yeah, that's exactly it. Yeah, the rules are valid. It's down to individual preference. What rules they're going to act on. Yeah.
Okay, thank you very much. There were probably even more questions, but for time reasons, I have to cut. I also invite everybody to actually join meet the finalists afterwards to clarify questions. This is a very exciting topic. We have seen it also from the many questions that we had in the chat. So there were lots of interest in how you exactly apply that. And I think what is nice in your case also that you build on something. I mean, James mentioned also that you had already worked quite extensively basically on this quality issues and also on the business rule engine in general. So to somehow can very nicely actually put that in your overarching approach. So this was also what was mentioned by the jury, by the way. So really, it's along the lines of making data science and data-driven approaches ready for data management. It's a nicely integrated approach and also a very good level of experience here. So Thank you very much for your achievements, for your submission, for your presentation.